Hello students, in this class we shall discuss resonance. We have already discussed all types of circuits, that is resistive, inductive, capacitive as well as RLC circuit also. In this class we shall discuss a phenomenon called resonance. What is resonance in AC circuit? This is a typical AC voltage applied to a series RLC circuit. Now this is the current. Now of course epsilon is equal to our V naught sin omega t. Now what is the impedance? We have already derived the expression for our current in previous class. So what was the expression for impedance? Impedance was R square plus XL minus XC whole square root over. Okay. Now let us suppose XL minus XC is equal to 0. Okay. Now this implies, okay, let XL minus XC is 0. Now put this value here. Z will be equal to R square plus 0 is equal to R. That means in the circuit when XL minus XC becomes 0, that means reactance part of the circuit is 0. Reactance is equal to 0. Then what happens? The total impedance becomes resistance, or the circuit behaves like a simple resistor. In that case, what happens? What happens? Your current expression we got in the previous discussion, that it will be I naught sin omega t plus phi, whereas voltage is this much. Now if Z is equal to R, then what is the value of phi? We know that tan phi is nothing but XL minus XC by R. Then this is equal to 0 by R, this is equal to 0, implies phi is equal to 0. Now if phi is equal to 0, then current becomes I naught sin omega t. That means the phase difference between voltage and current becomes 0. Okay, that means the current will be having the current will be oscillating with the voltage in the same manner. Okay, voltage is oscillating plus minus, current is also oscillating like that, plus minus. That means there is a rhythm between the voltage and current. They are having the same frequency and same phase. That's why this is called resonance. Okay, we have read in our 11th that resonance is a condition of frequency matching. When two frequencies, or if you to be typical about some vibrations, that is, if you hit a tuning fork, it will vibrate with some natural frequency. Okay, and if your hitting frequency is equal to that natural frequency, the amplitude keeps on going increasing. Amplitude keeps on increasing gradually, only because the frequency is matching. Okay, in that case you are saying this is a resonance condition. Why resonance condition? Because frequency is matching. Here you see they are oscillating simultaneously. Voltage is going like this, current is also going in the same manner. That's why this is called resonance. Okay, so what is the speciality of this resonance. So first of all, what is the definition of resonance? Resonance is the condition of a circuit when total reactance of the circuit becomes zero, or voltage and currents both are in phase. Okay, this is the resonance condition. Then what is the frequency at which this happens? Because XL is dependent upon omega, we already know it. Where to write? We already know that XL is equal to omega L, XC is equal to 1 by omega C. That means XL minus X is to be equal to 0, omega also has to be a particular value. Then what is that value? Put here omega L minus 1 by omega C is equal to 0, implies omega L is equal to 1 by omega C, implies omega square is equal to 1 by root over of LC, implies omega is equal to 1 by root over of LC. This is called resonant frequency. Resonant frequency. This is the frequency at which total reactance of the circuit becomes zero. Okay, this is all about resonance. In the next class we shall discuss the side effect of resonance. One more thing also here, what is its effect on current and impedance? Okay, now we shall study it. Look, Z is equal to this much. Now R is constant. If this part becomes 0, then Z becomes minimum. Z min is equal to R. So it will occur obviously at resonance condition. So at resonance condition, Z attains its minimum value. Now we already know that V is equal to I into Z. Now if Z becomes minimum, then I has to be maximum, so that V is constant, because voltage, that is V is equal to V naught sin omega t, is a constant, that is outside voltage. That's why V is equal to Iz. This implies V I is equal to V by Z, implies I max is equal to V by Z min. That means when Z is minimum, I has to be maximum. So at resonance condition, current is maximum, voltage impedance is minimum. That's all. Okay, this is all about from resonance in this class. In the next class we shall discuss more about resonance. Thank you.